Hello, this is Mrs. Denton, and in this video we're going to be looking at SOL G9. SOL G9 is all about quadrilaterals. It says the student will verify characteristics of quadrilaterals, which includes parallelograms, rectangles, rhombi, squares, trapezoids, and kites, and use those properties of quadrilaterals to solve real-world problems. Well, what I've made here is a giant Venn diagram of all the different quadrilaterals, and what I thought this would be useful for is so that we can look at their different qualities and understand how every quality, for example, that applies to a parallelogram also applies to a rectangle, a square, and a rhombus. So let's take a look at what it takes to be a parallelogram. The definition of a parallelogram is a quadrilateral with two pairs of parallel sides. So I can draw a very generic parallelogram, but here I've got three different examples of parallelograms. Let me draw a parallelogram that's not a rectangle, it's not a square, and it's not a rhombus. If a parallelogram is a quadrilateral with two pairs of parallel sides, then this could be an example of a parallelogram. Some things we see in a parallelogram are that while the opposite sides are parallel, they're also congruent. These two short sides are the same, and these two long sides are the same. So yes, they have two pairs of parallel sides, but they also have two pairs. Opposite sides are congruent. Okay. Some other important features about a parallelogram are its angles. Notice that we have two obtuse angles and two acute angles in the parallelogram. The obtuse angles are congruent to each other, and so are the acute angles. So opposite angles are congruent. Okay. Something else very important to a parallelogram due to the parallel sides are that while the opposite angles are congruent, the consecutive angles, one obtuse and one acute, are supplementary. So I've got two features about the sides and two features about the angles. I also want to really focus in on this special part of every quadrilateral called a diagonal. The diagonals I'm sketching here in pencil are really important features as well. Here I have one short diagonal and one long diagonal. But something to take notice about those diagonals is this point in the middle. That is a midpoint. So I can say that the diagonals bisect each other. They create a midpoint. So now I have several features of a parallelogram that we've written out. Okay, well, we can take that concept of a parallelogram and make it even more specific. We can take a parallelogram and straighten it up. That would create all right angles in the corner. That makes a square. Well, all of these features of a parallelogram still hold true. Plus, now we have the feature that all the angles are right angles. let's see what that does to the diagonals. We know that because a rectangle is a parallelogram, that this point in the middle is still a midpoint. Okay, what else can we observe? Well, now I can see that all four pieces of the diagonal are congruent to each other. So rectangles have congruent diagonals. In doing this, we've created a couple isosceles triangles here. This yellow triangle on the left is isosceles. It's got two sets of congruent sides, so therefore two sets of congruent angles. And that triangle is congruent to its vertical triangle on the left. So we've got a set of congruent triangles here. We also have a set of congruent triangles on the top and bottom of this shape. They're both isosceles triangles as well. So we've got two congruent triangles and they're both isosceles. The next shape I want to talk about is a rhombus. Notice, in order for a parallelogram to be a rhombus, it must have four congruent sides. So each side to a rhombus is congruent. Okay, so a rhombus still has opposite sides that are congruent, opposite sides that are parallel, opposite angles that are congruent, consecutive angles that are supplementary, and diagonals that bisect each other. Let's see what else happens in a rhombus. Draw these diagonals in. Okay. So since the diagonals bisect each other, that point in the middle is still a midpoint. Okay. Now, I see something distinctly different between a rhombus and a rectangle's diagonals. Here, I have one short diagonal and one long diagonal. Therefore, the diagonals are not congruent. However, the diagonals do meet at a perfect 90-degree angle. They're perpendicular to each other. So what we've created here is four right angles, which means we've created four right triangles. In fact, we've got a set of, that's a midpoint, so we've got diagonals that have been cut in half, and four congruent sides along the outside. So in this shape, each of the four triangles on the interior of a rhombus are congruent to one another. All four of these triangles are congruent to each other, and they're all right triangles. So when that happens, since each one is congruent to each other, we can count the diagonals as lines of symmetry. So everything on the right side of the diagonal is on the left side of the diagonal. Everything on the top half of a diagonal is congruent to the bottom half of the diagonal, because each of the diagonals is a line of symmetry, creating four congruent right triangles. Well, when you merge a rectangle and a rhombus together, now we've created a square. A square has all the properties of a parallelogram. It has all the properties of a rectangle with congruent diagonals, and it has all the properties of a rhombus with perpendicular diagonals. A square is the most specific of all parallelograms. Because of that, a square has 4 congruent right triangles, it's also bisected each of the angles. A square is symmetric in every possible way. So, I hope what you can take from this part of the Venn diagram is that we have this world of parallelograms, and some specific parts to the parallelograms are the rectangles, which are formed by all shapes with all right angles, and the rhombuses, which are formed by shapes with all 4 sides being congruent. Once those 2 shapes merge together, it creates a square. So that means a square is a rectangle, a square is a rhombus, and a square is a parallelogram. Isn't that interesting? These are our most popular shapes that are studied within quadrilaterals, but we have some other shapes that are important as well. Let's check out a kite. A kite is a quadrilateral. Notice it is not in the parallelogram bubble. In fact, a kite has no parallel sides. Instead, a kite's sides are congruent adjacent pairs. The 2 long sides are congruent to each other, and the 2 short sides are congruent to each other. Also, the diagonals are perpendicular to one another. They create right angles. The diagonal cutting the shape lengthwise is a line of symmetry. Everything on the top half of that line is symmetric to everything on the bottom half. So these angles have partners. All right, we'll get some practice with that shape in a little bit. Our last shape to talk about are trapezoids. A trapezoid is not a parallelogram. Parallelograms have 2 pairs of parallel lines, where a trapezoid only has 1 pair of parallel lines. Since it does have a set of parallel lines, it does have consecutive interior angles that are supplementary. The 2 angles with 1 dot in it are supplementary, and the 2 angles with 2 dots in it are also supplementary. There's a special kind of trapezoid that it's probably what you imagine, and it's called an isosceles trapezoid. It's still a trapezoid. All isosceles trapezoids are trapezoids, so they still have 1 pair of parallel lines, and they still have consecutive interior angles, which are supplementary. The additional piece to an isosceles trapezoid are its congruent legs. Since an isosceles trapezoid has congruent legs, let's check out what happens to the diagonals. In a trapezoid, there is no symmetry to be found, so the diagonals have no relationship to one another. In an isosceles trapezoid, we can cut this shape right down the middle vertically, and whatever's on the left is equal to whatever's on the right. This allows for the diagonals to be congruent. Okay, so we've listed out some of the features of each of the shapes that we'll be looking at. In our next videos, we will be looking at some examples of each shape individually. So happy studying!